Hi everyone, welcome back. With this video we are gonna get into the details of this Kalman filter class, and we are gonna start with the transition matrix. Actually there are three important matrices before we continue with this class we should learn, which is the first one is gonna be the transition matrix, and the second one is gonna be the measurement matrix, and the last one is gonna be the control matrix. These are three important matrices related to this Kalman filter class. We need to learn very well about these matrices so we can continue with the others later. So for this video we are gonna start with the transition one. Here we see, by the way, in the previous video also I directly showed this example, but I will not explain all of the code directly. I want to go by one by. So for this video we are gonna learn about here, and in the next videos I'm gonna explain the others, so we can learn all the concepts by one by and clearly. Okay, and also all of the code I'm showing in here I'm gonna put into my GitHub, so you can directly check from there. You can copy and you can try in your environment also. Okay, this is our transition matrix. Maybe before starting, since this is the first video about explaining the details, this is the constructor. If we go into the here, there are three parameters actually this Kalman filter is taking, the constructor is taking. The first one is the parameter which is deciding the dimensionality. Actually this can take until 6. For example, if you put 6, you need to consider all of the dimension, velocity and the acceleration. So you are giving all these parameters. You are already saying to the Kalman filter constructor, I'm gonna give all of these related parameters to you, so you can continue accordingly. So but for our case we are starting with the 4 dimension, which is we are only giving for this example we are just giving the dimension and also we are giving velocity and done. Also I'm gonna show at the end of the video with an accelerated example I already prepared in here. I'm gonna show you that, but we are giving 4, which is representing maybe we can write here about the dimension x and the y dimension, and after that we are just giving the x and the y velocity accordingly. And what these are meaning we are gonna understand in the transformation matrix side. Just keep in mind these are deciding the dimensionality, and the other one is deciding the not this one, dimensionality of the measurement. This is about the environment. For example, now we are by the way, maybe I need to show the example. We are now working on a 2D dimension, so this is deciding that. Maybe if you work in a 3D environment, for now we are going with the simple example. In the 3D environment you also need to give the z-axis, so it should be also included to your parameters. But now we are continuing with the 2D. Also this is deciding which kind of dimensionality you are working on the real world. And the last one is by the way, for example, measurement matrix is related with this one, transition matrix related with this parameter, and also the last parameter is which is control matrix. Currently it's 0, so it's not considered, but in the other videos, which is we are gonna explain about this control matrix. Also we need to add one more matrix so we can see the what actually is doing. So there is 3 matrix, so these 3 parameters also related with these 3 matrix. Okay, this is important before starting. So we can continue with the transition matrix, and actually if the people who are directly continue with this video, I suggest to watch the previous video so they can understand what this simulation is doing, so they can understand more clearly. Then they can back to this video again. This transition matrix, you see, for example, there is 4 column in each row, so this should be always square matrix. So if this is 6, so we need to give the transition, we need to update the transition matrix 6 by 6. The matrix will change according to this number. So now we are continuing with the 4. The first one is representing the x, the x dimensionality, y dimensionality, x velocity and the y velocity. So in the row side, for example, this is gonna control only the x dimension, this is gonna control the y dimension, this is gonna control the real x velocity. What I mean by real velocity, we are gonna understand by comparing in the example side, and this is gonna controlling the real y velocity. Okay, And maybe just experimentally, most of the times this diagonal is gonna always be 1. So in some specific cases we need to update these things, but it's gonna mostly all of them is gonna be 1. Just keep in mind. Okay. I want to stop this simulation, so I want to control with my keyboard. So I can run with this one things. All of these are some kind of default parameters, so we can continue in here. Okay. This I can little continue. Okay, maybe it comes to an edge. Let's see in here maybe, or above it, so you can see clearly. Okay, it can stay here, and this is the default parameters. Why I'm saying default? These are mostly is 1, which is meaning deciding the new. The Kalman filter is gonna decide the new destination. It's gonna predict. So this is representing the x. So for example, if the previous destination is maybe x previous, we can say, and this is gonna be multiplied with this parameter, which is 1 and plus, and it's gonna come to here, which is deciding the maybe the updating velocity, we can say, and it's gonna just multiply one more this one with the velocity and with real velocity, and it's gonna decide the new destination of the x by Kalman filter. So similarly for the y-axis in here, and these are the real velocities, and maybe just for example, now this is the example we stopped in here. Let's little change. I want to start with this one, which is gonna be very good to understand. For example, I increase really much, which is 100, and let's run the code what actually that parameter is doing, so we can understand. So I want to bring the point to the same place. Oh, sorry, I little distracted. Okay, anyway, let's run with the default again. This one we can close, and okay, hopefully this is the default one. Okay, it can stay in there, and this is, I think this one default and this one the new one. We can understand from the, okay, I think this one the updated one, which is 101, this one. Okay, now we are in this point, and let's see when is changing direction, how these default parameters are working, how it looks like. Okay, just run. You see this green is Kalman estimated point. You see it's little going wrong place, and now it's gonna update. But let's see how it looks like in here. Okay, it's also a little in the wrong part, the green, because it thinks it's estimating because all the data it observed in this direction, so it's thinking it's gonna continue with this direction. But now it's changing the direction, and let's see. Okay, it's coming here, and the default parameter side, which is this one, is now it's gonna try to update the real point fast. Is trying actually. Okay, but in here you see it's directly updating. So in here it's really fast, but in here it's slow. You see, still not update until it comes here, but in here it's directly updated. So I think you got it. So what we tried, we just changed here, so it's really faster updated because we changed this velocity. These are the velocity x and x1 and the y velocity, but these are velocity kind of the Kalman filter updating velocity we can talk about. We can call it maybe. Okay, so these are doing this job actually. I think it's really clear. So it's updating really faster. So if you're changing the direction much in your scenarios, so maybe you can put this parameter really high, so it's gonna update really faster. But if you put low values, it's gonna take time to update, as you can see in here. Okay, I think this one clear, so we can back to again. I want to close all the projects. Okay, and here now I want to talk about this x and the y dimensions, what these are doing. I want to run again with the default one. This is the current version, and now I want to change, for example, x dimension as 1.5. So these are, if you change from one to anything, so you are just gonna looks like giving an offset. For example, this is the current version and it continue in this way, but as you can see here, it's always giving, in each iteration is giving an offset, because we didn't give the one, which is meaning take the same dimension with the real data, with the observed data, but now we change it to the 1.5, so it's always changing the dimension in the x direction by the offset. And if we continue a little more, I think it's gonna, okay, it's gonna going something somewhere else, because we already not give the correct parameter. And if you try with the y, it's gonna do the same. This specific case, if you really need an offset, maybe you can update these parameters. And the last one also, this is the real velocity we talked about. Let's run the default simulation again, and just change the x velocity, x real velocity with 2, let's say. So now, okay, let's run again. So now we change the velocity. For example, now it's taking the velocity from the observed data and it's updating faster. But now we made it 2, which is gonna be 2 times faster in the x direction. So it's going little weirdly, because we change the velocity. Now it's taking the velocity 2 times faster with the real data. So it's, yeah, acting little weirdly also. But maybe if a changeable velocity without acceleration, in that case also you may need to update this parameter. And these are done for most of the important ones we already talked about. Now I want to show an accelerated example. Let's paste here. Just ignore other place, just focus into here. Now what we did, we just changed this one with 6. Now we are included these 4 before we talked about. Now the last 2 parameters is considering the acceleration, which is 0.5. Also in the same way, I also add an acceleration into this simulation. The object should be also accelerated, otherwise Kalman of course will not match the real object, so we need to give the same acceleration into the real object. Anyway, let's see how it looks like. Okay, now I just, you see it's gonna continue forever almost. Yeah, because we accelerated this motion, so it's gonna forever increase the velocity. But what we did in here, by these 2 parameters we already talked about, the last one is just about the acceleration. If you change this into 1, it's gonna getting faster, more faster, and this is in the y direction also, this is gonna increase the speed accordingly. This is about the acceleration part. And yeah, maybe also let's see, maybe we can check from 0 and see how it looks like. Okay, yeah, it's little sliding because Kalman filter accelerated, object is accelerated, it's not fitting faster, but yeah. Okay, so this is updating according to the acceleration, and this just want to show you how this, if you want to give an acceleration parameter, how you can give. I just wanted to explain that one. And yeah, I will also put this example into my GitHub so you can take and play with the parameters around. For this video, simply I want to talk about this transition matrix, what happens if you change the parameters accordingly. And yeah, I'm done for this video. See you in the next videos.